should. Right. Good evening, everyone. Welcome you all to the webinar on IoT enabled connectivity and application towards automotive industry. On behalf of IEEE Student Branch, IEEE Computer Society Student Branch Chapter, and Computer Science and Engineering Department of Green University of Bangladesh, I'm giving you a gracious welcome. I am Sayyidah Nabila Akhtar, your host for this session. Today we have among us Dr. Muhammad Arafatul Rahman, Senior Lecturer, School of Mathematics and Computer Science, University of Wolverhampton of UK as the keynote speaker of this session. Dr. Muhammad Arafatul Rahman received his PhD degree in Electronic and Telecommunication Engineering from University of Naples Federico II, Italy in 2013. He has more than 10 years of research and teaching experience in the domain of computer and communication engineering. He was an associate professor with the Faculty of Computing of University Malaysia Pahang. His research interests including Internet of Things, wireless communication network, cognitive radio network, 5G, vehicular communication, cyber physical system, big data, cloud fog edge computing, machine learning, and security. Dr. Rahman has co-authored of around 100 prestigious IEEE and Elsevier journals. His name was enlisted inside the world top 2% of scientists list released by Stanford University under the category of citation impact in single calendar year 2019. This session is graced by the presence of the Honorable Pro Vice Chancellor of Green University of Bangladesh, Professor Dr. Muhammad Abdur Razzaq Sir, as the chief guest. And this session is chaired by our Honorable Chairperson of Department of Computer Science and Engineering, Professor Dr. Muhammad Saiful Ajad Sir. Now I'm handing over the session to Professor Dr. Muhammad Saiful Ajad Sir, our Honorable Chairperson of Department of Computer Science and Engineering and the chair of this session.
Thank you, Nabila. I think you have already introduced Dr. Muhammad Arafatul Rahman. To be honest, we did masters together under the same supervisor, and afterwards we did PhD from the same country, but not the same university. I was in Padova, he was in Naples. Even before joining UMT, we worked together. Even before joining in Green University, actually, we worked together in UMT. We had many papers together. So already you already get the introduction of Dr. Arafatul Rahman. Now I'm requesting Dr. Arafatul Rahman to discuss on IoT enabled connectivity and application towards automotive industry. Actually, he has several papers. He has several research fund on this particular topic. So I believe that you guys are going to get really many information regarding this and some guidelines how to do your research or how to think your research in that particular direction. So I'm requesting Dr. Arafatul Rahman to start his keynote session. Thank you.
Thank you, Dr. Saiful. First of all, I would like to thanks Honorable Chief Guest, Prof. MD Abdur Razzaq, and also Dr. Saiful. He is not only my colleague, he's my big brother and my friend as well. And thanks, Nabila, for your nice introduction. So without further delay, I would like to start my presentation of today's talk, which is IoT-enabled connectivity and application towards automotive industry. So let me share my screen. Can you see my screen?
Yes, we can.
Yes.
Okay, so basically it's a knowledge sharing sharing session. So although it's a very wide area, so we will try to cover a few things and let's see how we can go. So I organized the presentation like this. This is the outline of the presentations, as I know that you guys know about IoT, but those who are not familiar, for them, I will give a brief intro overview of IoT. Then I will directly connect to IoT towards automotive industry. And I will try to raise some issues. And then I will share some of our contributions on this domain. And there will be Q&A. So IoT, that means the Internet of Things. This is really a cutting-edge research domain with the thanks to the advancement of wireless communications and a lot of technologies. Now people want to connect everything, so that's why the concept of IoT is getting popularity. So IoT basically it will integrate sensor networks, internet, mobile communications, cloud computing, intelligent information processing, so and so on. So in short, we can say the Internet of Things it will basically uh, concentrate on information service, integrating the computer systems with the perceptions, cognitions, that means intelligence, influence, and control of the physical world by the isomerous connections between core networks and the terminals. So basically, these IoT can be categorized into power aspects on it can be network centric, it can be internet centric. So when it would be network centric, you can exploit this IoT on your own domain, on your own network. Even you don't need to connect our internet connections, or you can combine your networks to the internet, and you can accomplish some your task. So if we think about some talk about some IoT structures, we can categorize in this way: application oriented IoT. So let's say people oriented IoT. We can also talk about industrial IoT for social networks. We can talk about the vehicular communications. Basically, today's talk, we will try to highlight some of these vehicular communications. When we talk about the IoT in terms of architectures, it can be sensor layer architectures, it can be network layers, and analysis layers and applications. And in terms of technology, there are a lot of technology can be connected. For example, RFID, we can use Zigbee, Wi-Fi, XB, and a lot of things, even LoRa. These IoT can be exploited in human-centric applications. For example, we can use for body area network, intra-body area network, and inter-body area networks. Also, we can exploit it in big data applications in order to move towards smart cities. And for those who are interested, especially the young scientists, those who are joining for today's talk, you can play and you can try to exploit these IoT in a simulator tools. For example, you can try for OpNet or Riverbed. So I already give a reference book here. Okay, so which is OpNet IoT simulation. You can explore more, and I do believe this book will help you a lot for the young researchers on this IoT domain. Well, so basically we all know about the IoT. That's why the basic part I will not go in details. Rather, I will give you some scenario so that you can imagine how you can introduce IoT for solving your problem. So that's why the scenario is related to industrial IoT. In short, we can tell IIoT, which is another interesting, catchy topic nowadays. If you have a look on the research domain. So let's have a look in this big picture. Basically, we will have our industrial networks where we will have lots of nodes. So this node can be fixed node, can be mobile nodes. And what this node will be tagged with the IoT box. So what is this IoT box? Basically, this IoT box will have three functions. First, it will collect the data from the environment. So that we call data acquisition through sensors and actuators. So after getting this data, you can get lots of data. So we can also connect IoT with big data. So because all together, it will help you to solve the problem. So when we will talk about the big data, in that case, the important thing is, big data can be a problem if we cannot handle the data properly. So what does it mean? That means through the sensors and actuators, when we receive the information, we should get the proper information, important information, not the all the information that we acquired. We should not pass through, because in order to transfer this information, store this information, somehow you have to spend the money cost, because communication cost and so storage capacity and so on. So in the data processing unit, that will be basically controller that will get the data, take the decisions. And in the lower end, in the age part, you can also reduce the unnecessary data. And once the decision will be made locally, then this data can be transferred through transceiver, and this data can be go to through the backhaul network, and the information can be stored in the cloud. So this backhaul network can be, we can use anything. We can use WiMAX, we can use 4G LTE, we can use 5G, even we can think about 6G, because a lot of diversity of nodes that connected in these IoT networks. That's why researchers are moving forward for intelligent networks. So 6G and 5G, they are more or like intelligent network, where the challenge are scalability and heterogeneity and so on. So that is after getting this data, when data will be stored here, again, you can do some processing so that you can eliminate the unnecessary data. Here, the data elimination will be locally, and here the data elimination will be globally. And then there will be interesting part where the stakeholders will play an important role, because once you will have a data, what you will do, you have to exploit this data based on the policy of the government, NGOs, some organizations, those who are involving for these industrial networks. And then based on their policy, we can introduce a lot of service and management. For example, monitoring systems, maintenance systems, surveillance system, and maybe we can think about the supply chain traceability, which is also very important and interesting area to go for further exploration. So this is the general overview that will help you to think how you will exploit IoT for solving your problem. So that is the overview. Now, I will narrow down my talk and move towards IoT, IoT towards automotive industry. So I will give you a brief discussion, but those who are interested for getting further information, please have a look on these references. So you can explore and get more details from this paper. So first, I will try to highlight another scenario so we can raise some challenges. Okay. So what is automotive industry? Basically, it comprises with a wide range of parties or entities that will be involved in designing, development, manufacturing, marketing, and so on for motor vehicles. Okay, so in this domain, IoT can play an important role where we can integrate stakeholders, process, data, things through network connections, and then we have noticed that lots of road accidents and so on, and other important aspects can happen because of improper, less effective technological solutions. So in this scenario, what I am trying to say, let's say this is our road where we have lots of car. This car is moving. Okay, so and then if we zoom this this car, and we will see inside the car we will have lots of sensors, because if we think about our upcoming car, I mean, future car, it would be driverless, it would be already electronics car is available. So where basically lots of sensor will be. So what we can do, we can do some things that, let's say this, in order to monitor the structure of the car, we can think about a health diagnostic center of the car. Okay, so there will be a challenge and issues and an idea that you can think about how we can design a vehicle health diagnostic model inside the car. So then once you will gather some data from your car, you can share this information to other entity, so that this information can be further exploited by the industry, and this information can be shared with the owner, with the driver, or even the government agency for the further investigations. So how we can transfer this data? In order to transmit this data, we should have some communication, some networking domain that we call IoT-driven heterogeneous network. Why we are talking about heterogeneous network? Because look, let's say the communication will take place inside the car, and then communication will be in order to transmit this information inside the car. This car, when it moves, it can share through data. I mean, handover zone. So there will be lots of data handover zone that could be in your house, exploiting your Wi-Fi connection. It could be petrol pump. It could be traffic signal. So when we are talking, these challenges basically, I highlighted this problem based on keeping in my mind of the smart city. So when we will think about the smart city, so this kind of platform will be available. So once this car will go, it will share this data, and then from this petrol pump or data handover zone, data will be transferred to the cloud. So there will be several level of communication: intra-car communication, vehicle to interface, and interface to cloud. So that's why we call this is a heterogeneous network. Will play an important role here. So when we are talking about network, we have to also pay attention to things, how we can ensure the security. So there are two ways of security can be done here. One will be data security, and another will be network security. So so there will be an interesting opportunity to explore something security in this network. And I want to tell you something, that this Internet of Things, this is a resource constrained network. So we cannot exactly collect the existing solutions of our existing network and directly impose on this Internet of Things. Why? Enable network. Why? Because due to the resource constraint, you will have a energy consumption, limitation of energy consumption, and device computational complexity. Okay, so once we gather this data, let's say in a central entity, and there will be a lot of opportunity to do this data handling, where we can use some AI tools, we can use applied machine learning, deep learning, and so on. And then there are several services can be introduced. So so that would be another level of challenge. So from this slide, what I am trying to give you, the message is there are a lot of opportunity you can highlight if you want to work in automotive industry. Well, so now I will talk about the IoT connectivity technology for automotive industry. What kind of technology can be incorporated with this? We can definitely use vehicular communication technology for a V2I, V2V, VANET, also the wireless sensor network, for example, Bluetooth, Zigbee, XB, and for LoRa, we can use TV wide space, which will help us to solve the spectrum scarcity. As you know, that TV wide space, the spectrum we can use multi-spectrum and which is free, uh, which we can use when the TV, the main TV user are not using, so and so on, cloud technology. So these all can be incorporated with your IoT enabled solution for achieving your goal. And then we can have a look, lots of applications of IoT in automotive industry, where the IoT is exploited for real-time vehicle navigation, for toll collection, for traffic management, for security and anti-theft, automobile parking systems, emergency vehicle management system, vehicle exhaust and pollution monitoring systems, driver physical condition monitoring system, vehicle performance and engineering monitoring. And finally, we can also introduce a lot of supply chain issues. So throughout this framework, what we are trying to say, all these applications can be somehow connected with a central entity where the data will be collected, and some stakeholders, for example, government, government along with some NGOs or some industry, they can exploit it and get benefits from this common platform. Well, so in our work, we also introduce some conceptual idea for vehicle health monitoring, where basically we will have a lot of users there, those who needs information from this vehicle monitoring system, who they are vehicle owner, driver, manufacturer, and engineers. So what they are getting information from sensors and a lot of devices, and based on this device, there will be a decision engine. So basically, this decision engine will analyze and provide some output, and based on that, a lot of services will be provided to the requester. And same goes to a similar way, we can also solve the real-time monitoring issues, and as well as real-time transportation and management systems, where the inputs will vary from different sources. So these are the some introductory part of IoT towards industrial informatics. So now we will share you some of our contributions in this domain. So the first one, we'll talk about IoT enabled intra-vehicular network. So when we, I mean, inside a car, in car, how we can introduce the IoT and solve the problem. So from this problem statement, we can see the hundreds of sensors can be exploited inside a car in order to make it more efficient, in order to make it smart, in order to make it driverless car, and so on. So what does it mean? Does it mean that in our existing car, we don't have sensor? Yes, we do have, but how they are connected? They are connected through the canonical network, okay, that we call CAN. So that is connected through bus. That means where. So let's say, just imagine if you want to introduce large number of sensors inside your car, and if you are connecting through where, so yeah, what would be? There will be no room for you, right? So it will be quite messy, and the weight of the car will be increased. And if the weight of the car will be increased, that means the fuel consumption will be increased. So how we can solve these things? We can solve easily by replacing wire to wireless. Well, so that can solve the problem, but the issue is when we talk about the wireless communications, it's not quite straightforward, okay? And especially inside the car, there are a lot of problems. This is not wireless communication friendly environment. So normally, in ideal case, in wireless communication, we think that there will be an empty place where we can transmit the data. There will be no collision and so on. But if you notice that this environment is quite harsh environment where a lot of obstacle is inside, and because of that, there will be a lot of effect. For example, scattering, reflections, and fading effect will be there. So what we have done, in order to check the existing communication, existing technology, how it's worked. So that's why we design a network scenario where we keep on base station, and then a lot of sensors are connected and they are communication. And this is we use star topology, so one-to-one on-hop communication. So when we are doing on-hop communications, in this case, the MAC layer can play the role. So we are using existing CSMA CA technique. And what we notice that when the number of node is increasing, and when the traffic load is high, the performance of the existing uh, CSMA CA is not performing. So this is our findings. Okay, so in order to solve these things, what we have done, we propose a very simple solution that is called history-based MAC strategy. So what it does, how it works. Basically, you know that the CSMA initially it set its communication parameter, okay, and then depends on the scenario of the network, the parameter will be changed. Okay, so what we have done here, we use the previous history of the network, and we tune the network so that we don't need to spend time to set up the network every time. So for a successful transmission, we will always use the historical information, so that will help us to exploit the contention access period optimally. So after that, we have noticed that our proposed solutions is outperforming, and it is almost performing. If we use, definitely, if we use two base station here, the workload will be distributed, and that is the case here. So which is similar like our proposed solution. But even though this solution will not be really a good one if we increase large number of nodes. So then we come up with another solutions for this communication, in order to establish a communication for monitoring the car health. So what we did here, we divided this communication phase in two parts. One is normal phase, another is emergency phase. So normal phase is just take an analogy of our health. Okay, so let's say every 6 months, we are doing some regular test of our health to know whether any problem is happening or not. So this is our normal phase. So this phase, what we are proposing that we will go for like TDMA approach. Okay, so we'll have a priority. Which one has priority first, it will go, and then in this way, all the components will transmit. But in between of this first test and second test, in between there might be a probability that you are suffering fever, you are suffering a lot of things, right? So what you will do, that if that we consider the emergency phase. If you have anything, then you need to again go for the test and so on. So now bring this analogy to the car. So inside a car, we have a lot of sensors. So the normal phase, the car will communicate like this. But during the emergency phase, if any malfunction is been noticed by any devices, then it will start communicate, and that will communicate again based on the hierarchy. So this is the concept of priority MAC strategy. And finally, what we have done, we propose a hybrid MAC strategy. This hybrid MAC strategy, where we will use the history-based MAC strategy for the emergency phase, and the normal phase we will use priority MAC. And what we have noticed that our hybrid approach really outperforms in a scalable network, in a large network, and also the throughput is increasing. Okay, so if you want to have more information about these, I would suggest you to have a look on this paper, which is published in Computer Communications. Okay, so then I will move to another interesting topic where we can also exploit IoT for highway lighting systems. So for further in detail information about this, you can explore our paper that is published in IEEE System Journal. Okay, so I will explain you briefly what is the problem is. So as you know that in the traditional highway lighting, all throughout the entire whole night, no matter whether there is a car or not, the light is turning on, right? So this is the normal and traditional highway lighting system, but which is very, very expensive one because you are not utilizing the light properly. So if we want to make it, if we want to use this light efficiently, what we can do, we can simply add a sensor, and if there is a car, we can turn on the light. So it will solve the problem. But the 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 main problem of this solution is during the night time, if you are driving and if you reach to the lamppost and it will be turned on. So this fluctuation of light will may cause the accident. And moreover, when you are driving your car in a highway, so let's say this is a highway where you are paying the toll, right? So when you are paying the toll, you don't want to get this kind of experience. Okay, so you want that the entire road should be smooth. There will be no problem of electricity. So this is from the user perspective. And whereas those who are providing the service for this highway, let's say government or other particular companies, they want to minimize the cost for this lighting cost, right? So we have to provide a solution that will happy for the both parties. So what we have done here, we this is the architectures what we plan for our solutions. So what we did, we divided the entire let's say we have 100 kilometers of a highway, and we divided into the 10 pieces. So one sector will be 10 miles, let's say 10 kilometers. So what we do, we will we will we will work on a particular section. We will not turn on entire 100 kilometer. Rather, we will work only particular section. So this particular sector will be depend on the eye vision. So look, when you are driving, so your concern is how far my eye vision is. If the light is there, that is that then I'll be happy. I don't care beyond my eye vision whether the light is turned on or turn off. That doesn't matter for me. So that is the concept that we use. And then what we have done, we use something here we select the distance D which is more than the sector in order to make the light seamless. Seamless means when the light will be turned on or turn off, the driver who is driving, he will never realize it. Okay, so that's why what we do, when a car will come, there will be device stacked with this lamppost. This lamppost will turn on all the light up to the D. Okay, so as you know that we are transmitting with the signal which is much more faster than the car. Okay, so this entire portion will be enlightened. So once this car will become here, we call this is an anchor node, which is smaller than this. Then this node, what it will do, it will again turn on the next sector. So in this case, when we are passing through, we already find all the light is enlightened. So that will help us to make entire systems seamless. Okay. Using also IoT, what we have done, we also, let's say we use our component attacked with the lamppost system, lamppost, then there might have a chance that the lamppost is not working or not. So what we have to do, definitely we cannot go for the manual way to identify. We can do it also automated maintenance system. So we use some simple algorithm to do that. Okay. For example, once we are transmitting the packet in order to turn on all these things, that means if there is no lamppost is not working, is not there is no malfunction. That means when I receive a packet here, that means I mean the first ID of the packet should be from this. But if there is a malfunction, that means the if let's say if this is not working, or these the previous anchoring node is not working, then what this anchoring node will do, it has also the capability to identify the presence of a car. In that case, it will use its own lamppost ID in the packet. So this algorithm will identify that, okay, first ID should be this, but why this is the first ID? That means there is a problem in this sector. So the maintenance team will directly go the sector and they can identify what is the problem. Well, so we have done some cost analysis in order to validate the proof of our concept. And we have noticed that, look, if the road is entirely busy, I mean 100% busy, then our solution will work similar like the traditional one. But in reality, the entire night, the whole the road is not busy, right? Especially the later part of the night. Sorry, the road is less busy. So if the road is overall 10% busy, how much cost we can save from here we can see, and what would be our, how we can get our return of investment. So if the road is 10% busy, we can get the return of investment within within 1 year, and if it is less, then it will be increased. So it depends on the on how much energy you need. And finally, we also analyze the seamless lighting concept. So seamless means, I mean, there will be no hassle where driver is driving. He doesn't want to get any kind of experience that there is no light in the street. So that will be depend on the malfunction of the light. So basically, the seamless will depend on three parameters: on is bursting a period, another is system outage probability, and the malfunction of the devices. Okay, so we have noticed that, look, if we use, let's say, we can use different communication technology here. We can use Zigbee, we can use XB, we can use LoRa, and so on. If we use Zigbee, okay, in that case, as you know that the transmission range of Zigbee is really less. So in that case, almost every node we need to tag our devices. So the more device we need to tag, that means the cost will be high. We can replace it by using high range sensor device that is, let's say, LoRa. So if we use LoRa, we can use, let's say, one on device in the starting and another device in the anchoring point. So entire section we can use only two devices. So it can really save the costing of our costing of the system development. But look, the dependency of the entire light will depend only these two lights. If these two devices are not working, that means these will be blackout. So that is the problem. So there is a pros and cons. Okay, if we use Zigbee, and then definitely the average burst period will be less. But if you use LoRa, it will be high. So what we propose here, instead of using Zigbee, we can go for LoRa, but we will not use single LoRa for each anchoring point. Rather, we will use redundant. If we will use redundant, then the probability is really less that two devices will not work at the same time. So that will also solve the problem. and ensure the seamless. Okay, so then we will talk about another interesting topic. As you know that IoT is using now it's really a popular thing, but one of the thread of IoT is security, because most of the spectrum that we are using for transmitting our data, that is free, unlicensed spectrum. Okay, so in that case, how we can ensure the security. So this part we will try to give a brief idea of the security. So for details discussions, you can again have a look of our paper, which is published in Elsevier Sustainable Cities Journal. Okay, so the concept is very interesting and simple. As I told you, the ideas, the traditional ideas for traditional network, it requires high computational device, because you need to run the software, you need to analyze the data and so on. Okay, the model requires a lot of computational device capability, where IoT is a resource constrained network. So IoT device, basically it has less battery consumption, and the computational complexity capability is less. So we cannot directly bring these ideas, intrusion detection system that we use in the traditional network, and you exploit it here. No, what we have to somehow introduce some lightweight idea system. So how we can do it? So we propose a solution exploiting distributed approach. So what is this? Here, if we use the ideas for a centralized approach, so all the process, I mean, after identifying the features, the classifier will do the classifications, and the multi-level perception will classifier will identify what are the threats is noticed in that. So everything will be in a single entity, and that device will be really high computational capability. Okay, but we propose first the semi-distributed one. In the semi-distributed one, what we have done, we divided the entire features into a section, separate part of the features. So a small part will be done and handled, and finally handled by a set of network, okay, devices, and finally the main multi-layer perception classifier will be done in a specific node which has capability for high computational. In this way, we can reduce the load of the network. Okay, this is the semi-distributed. But in the distributed ideas, what we have done, this is solely designed for the IoT network, where we divided the features, okay, into several parts, and only particular feature will be handled individually in a multi-level perceptor as a classifier in an individual devices. So these all the devices are not high computational capacity capable. So what finally it will do, it will just send its decision, and finally it will send to the controller. So the controller will basically handle the decisions, and it will let the network know whether there is any suspicious activities is happening or not. So definitely we cannot expect that this distributed approach will provide you 100%. Basically, we don't need one. Why? Because here we know the constraints. We cannot provide all the support in terms of better energy consumptions and computational capacity. So we cannot expect that our solution will be 100% or 99% and so on. As we see in the centralized approach is very high in terms of detection rate, accuracy, F1 scores, and correlation coefficients. So what we notice that in distributed approach, this is like 94%. So we are happy with that. Why? If we notice the second part of this result, we see that, look, if a centralized approach, this is the traffic, this is the time to build the model. We need really, this is very heavy. So that's why we need high computational things. Whereas if you see our distributed approach, it is really quite light. So that is the interesting findings we got, and this is one of the elementary level of work. And that time that there as far as our knowledge, there was no paper was addressing this kind of ideas for the IoT network. So later on, I do believe you will get a lot of solutions, and you can explore more those who are interested in this domain. So I don't want to linger my presentation on a lot. What I am trying to give you today's talk is to give you some overview of IoT, then narrow down my work and focus on industrial automotive industry. And then I try to discuss some of our contributions. As I told you, this is a wide area, so you can do a lot of work here. And then I would like to utilize this opportunity as we are involving with a lot of upcoming events. So there will be some IEEE conference and so on in Dhaka, December, and also in Yemen in November, where we are getting lots of scholars, for example, Prof. Atik Jamans and some scientists in cybersecurity in Canada, UK, and also for Bangladesh. So if you are interested, you can join, and you can also get some information from them. I do believe that will help for to gather information for the young scientists as well as our co-researchers. And then what are the opportunities we can get? I would like to do the collaboration with those who are involved in research. So we can do some collaboration for joint publication, editorial, organizing conference, and also doing joint supervision. And if anyone interested for post-graduation study, you can explore our website. And there is another, those who are interested for postdoctoral fellowship, especially in July, there will be an opportunity for medical postdoctoral fellowship. If anyone is interested, please contact with us. And we have a very good research group, so we can share more, we can discuss. And that's why if anyone is interested, they can join with this research group. So with that, I would like to conclude my talk. Thank you very much for your attention. The floor is open for Q&A. Thank you.
Thank you very much, sir. So now it is the time for question answer session. Dear participant, if you have any question, you can directly ask your question to our honorable keynote speaker. And of course, you can put your question in both Bengali and English. So we got a question here.
Okay.
Um, Muhammad Jahidul Hassan asked that, what are the uses of blockchain technology in IoT?
Well, that is very important, interesting questions, Mr. Jahid. Basically, last part, I talk about some security aspects. So when we talk about security, there are two parts. One is network security and data security. Basically, one of the key component of data security is integrity. So blockchain can be exploited there in order to ensure the integrity part. And as IoT, there are a large number of devices and need to work together. So the main concerning issue is scalability. So that would be a very interesting area you can explore, and also the heterogeneity. So if you are interested to explore this area, you can have a look on my recent work that is published in IEEE Industrial Informatics, that is especially on scalable issue. You will find more details there. Thank you.
Thank you, sir. We've got lots of questions. Um, so Badhan Parvez asked that, can I involve IoT in machine learning?
Well, definitely, because what IoT will help you, it will help you to gather the information. And if you notice the scenario that I discussed in my slide, so after gathering this data, what you will do? Basically, you will exploit. You need to use this data for solving some problem. So there is the place where you can use machine learning to develop your model for providing some service. Okay.
Thank you, sir. Jania Sharmin wanted to know that um, the IoT robot and its chance in digital world and the opportunities.
What is the question?
Jania Sharmin, can you please clear your question, please? So maybe she wanted to know about the opportunities and in
Okay, okay,
digital world
I got the question.
about the IoT
Okay,
robot.
okay. Whatever I understand, okay, I can share. I can tell. I'm trying to answer. Okay, normally when we are talking about robot, there are a lot of contribution can be done. Okay, so as a robotic aspect, but nowadays what we can do, we can use that robot for solving social problems. So we can drag these roboting aspects and bring it to the communication part where the robot can talk. Robot can solve the problem by in a collaborative way. So in that scenario, IoT will play an important role, I do believe.
Okay, so Quadri Wasim said that, can you suggest some papers related to intra and intervehicular networks?
Well, we can definitely suggest. I will ask you to explore my Google Scholar, and you will find a lot of paper in intra-vehicular communications. And you can also explore. My suggestion is try to find some IEEE transaction or Elsevier, where you will find lot of materials there. If your university has support for because it needs subscription, right?
Thank you, sir. And it is the last question from a participant side that uh, can I know Python and JavaScript languages uh, are be efficient IoT machine learning in future?
Well, I don't want to go any specific language, but rather I love to talk with the programming concept. If you have a programming concept, that is very important. And you can use any programming language. Let's say nowadays people are moving towards Python. Who knows after near future whether it will be or not. But the important thing is you should have the programming knowledge. You should have the logic inside. If you have, you can definitely explore and prepare yourself and cope up with any language.
Thank you, sir. And it is the end of our question and answer session.
Thank you very much,
Thank
Nabila.
you a lot, sir. Now we can move to the next step of this webinar. I would now like to request Professor Dr. Muhammad Abdul Razak sir, the Pro Vice Chancellor of Green University of Bangladesh, to address the gathering.
Sir is out for some minutes. He's going to join soon. By this time, if you audience have any question, you can continue asking question to our keynote speaker. Please carry on.
Yes, sir, we are getting more questions. May I proceed, sir?
I have a question. I already text.
You can ask directly that to our keynote speaker.
Hello everyone. Hello, Assalamualaikum. I was muted just because of that. Okay. Anyway, am I audible?
Yes.
We are working on IoT-based system, and recently we are receiving the IoT. Then we are decoded team. I'm Muhammad Tariq Islam, and 192 batch. And very first, I would like to share you that we're working about the IoT platform. We are working many days. Recently, we are achieved this award of ICT Basic ICT Award 2020. So this system is based on IoT air pollution monitoring system. Now I have a question: the which system I have to be focused on more to be success or such like is which there is a lot of sections such like blockchain, machine learning, and there are home monitoring, air pollution monitoring. Is there is a lots of things, but which section you have to know more, much more to improve us or our team? That's my
Okay, thank you.
question.
First of all, I would like to congratulate you along with your team for your success and achievement. Okay, so your question is quite wider question. So you used IoT for solving something air
Yes, sir.
pollution, right?
Yes.
So basically now, whether you will using machine learning, whether you will use blockchain on and so on, that will depend your objective. What is your objective? What you want? Keep your mind. IoT will help you to gather the data, okay?
Yes, sir.
Because it is related to the communication part. Once you have the data, then you can exploit this data, and that would be the data analytics part, where you can use any AI concept to to handle this data. And if you want to add some security and all these things, especially data security, then you can go for your blockchain or some other thing. So you have to identify the problem first, what you want. So that is important. So it will depends on, okay, let's say you are getting a project from a government,
Yes, sir.
okay, and then they have some objective,
Yes.
okay. So these based on their objective, you have to work. If they want security, you can work also in the security. If they want to identify some prediction model, then you have to use the machine learning. Do you understand what I
Yes, sir.
mean?
Yes, sir.
What I
Yeah,
mean?
yeah, yeah.
So it depends on your objective. If you don't need anything, if they want only the infrastructure together to dump the data, in that case, you don't need anything. You just need only the communication infrastructure. I hope you got my answer.
Yes, sir. Thank you. Thank you very much, sir.
Thank you, sir. May I now request Professor Dr. Muhammad Abdul Razak sir, the Pro Vice Chancellor of Green University of Bangladesh, to address the gathering.
Thank you very much, Saudana Abil Akhtar, for your nice anchoring. I was carefully listening today's keynote speaker, Dr. Muhammad Arafatur Rahman, focusing on industrial applications of Internet of Things, more specifically automotive industry. It was educative, directional, and thought-provoking. I pay sincere thanks to Dr. Arafat for spending his valuable time for the students of Green University of Bangladesh. Well, IoT is one of the most influential technology now, especially helping us to monitor the physical systems in real time and produce numerous amount of data using very low cost devices so that intelligent decisions can be extracted from those data processing. And automotive industry, transportation, health sector, and many other areas can be better managed, and business processes can be more efficiently handled for the higher productivity, higher security, higher reliability, and so on. So learning about IoT and to explore the potentials of IoT in solving many real life problems in a society is an urgent need, also is an important uh, a call to the engineering community to pay their valuable time and research efforts. Well, fortunately, I do have huge overlapping in the areas of research topics that Dr. Arafat, Professor Saiful Azad are focusing on. I was involved in a number of real-time projects related to Internet of Things within the country and outside. Let me share one or two out of those. Well, I got an international fund from Information Society Innovation, the Information Society for Innovation from Brisbane, Australia. And that project focused on driver distraction monitoring for transportation safety. That means when drivers are driving cars, often they are being distracted, especially due to the diverse use of the mobile phones and its applications. The level of distractions has been further increased. So what are the IoT devices that can accurately, precisely capture different types of distractions related to eye movement, related to taking alcohols, related to drowsiness, related to over speeding, abrupt braking, violation of traffic rules, etc., and how to warn him, giving the driver warning, as well as severe cases can be reported to the vehicle owner and or the transport manager, and how we can store the driving behavior of a driver over the long period of time in a cloud database, so that that can be analyzed and a portfolio for that particular driver can be generated for further recruitment or his or her uh, 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 career upliftment and so on. So that was an interesting work, and later my team developed a prototype and worked in a research team outside the country in Kingdom of Saudi Arabia, and got some significant improvement as well as the publications as well. So these are really instrumental and very fundamental areas to solve in our country as well. In another project, I was involved related to real-time monitoring of base stations in different corners of the country. You see, in our country, the electricity comes and back. I mean, load shedding is very frequently happening phenomena in our country. So under each and every base station, there is a generator. and there are some battery storage devices, so that the services of the base station can be made uninterrupted even though electricity goes out. Now, question arises: who will manage those generators, fueling, refueling, repairing, maintenance, and many other activities? Well, typically mobile network operators outsources this task to different uh, corresponding companies, small companies in the rural areas or the suburban areas. And what is happening there is unfortunately, but the cost is becoming increasingly high due to the uh, 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 misappropriate reporting of the load shedding period and the uses of fuels over there and the maintenance required for the generators and other battery and other devices over there. So we developed some installed some sensor devices. Around 28 sensory data were collected from some 10 base stations as a first node deployment. And from the center, I mean at a central office located at Gulshan, those generators can be real-time monitored. Even the generators could be shut down and turn on and turn off by putting several commands from the central administration office. And many other refueling amount, current fuel amount, etc., can be monitored, and what was the actual load shedding period can be tracked from there. So it was another important project where I found efficient utilization of the resources can be ensured by deploying the Internet of Things devices. It's very low powered, low cost, and require very low bandwidth to operate over there. And definitely this was another very fundamental problem to solve. Well, I was also involved related to an infrastructural security project conducted by the government of Indonesia. That was also very much important. Well, due to some, I mean, security reasons, I won't share with you the details, but that was definitely a very important one related to securing some sophisticated areas as well as the national monuments of the country, and the devices and the infrastructure that they developed is really encouraging for the efficient management of the country's sophisticated areas. So definitely, there are numerous areas to work with. In health industry, IoT has the use of IoT is exponentially increasing for the health sector. Our keynote speaker focused on automotive areas. That is also another uh, important area. I was noticing that he was discussing about efficient data collection process from hundreds of sensors to a particular base station in a running car, and what MAC protocol can significantly improve the performances based on priority setting of the data types, as well as the urgency level, considering the urgency level of the data sources. These problems are also very much important. And very recently, I believe uh, some smart uh, concepts related to the use of Internet of Things devices, or the controlling of the Internet of Things devices with software defined systems, and ensuring the security of IoT devices by introducing blockchain concept. These are coming in the recent areas. So our students, those who have interest in these areas will find very interesting problem, that is exploitation or exploration of multiple technologies uh, working together to address particular important societal problems, uh, uh, maybe investigated by our students in future days. So with this few note, and thanking the keynote speaker and the chair of the department and the IEEE Computer Society student branch of Green University of Bangladesh, IEEE student branch of Green University of Bangladesh, and all the faculty members, their guests from home and abroad, and my dear students. I believe this evening was a very educative one and was a thought-provoking one, and this will help us a lot. I believe the IEEE student branches and the department will continue arranging such scholarly discussions in future days to promote many students to engage in research activities. Thank you very much again for giving me a floor to share a few words with you.
Thank you very much, sir, for your valuable presence and your inspiring words. Now, I would like to request Professor Dr. Muhammad Saifulajit sir, the chairperson of Department of Computer Science and Engineering of Green University of Bangladesh and the session chair of today's webinar, to say a few words to us.
Thank you, Sayyidina Amina, anchor of today's session. Honorable Pro-Vice Chancellor, respected faculty members, my dear students, the guests from home and abroad, and others. Assalamu alaikum. Very good day. So, as Pro-Vice sir was saying that this session was really educative, and I believe that you get many information regarding, the IoT related activities that are at present going on. So there is huge scope, to be honest, to explore. So you get some information from the keynote speaker. Our professor also was giving some information where you can actually explore, to be honest. So I believe that from this session, you get some directions where you can explore more on, on IoT related research. Like our keynote speaker was saying, he actually discussed different areas of IoT where there is a huge possibility of exploring. So please, those who are interested, you can always contact our keynote speaker. You can also contact me. You can also contact our faculty members who are working in, in computer networking and IoT related fields. And the good thing is, at the end of the discussion, our keynote speaker already give his, details regarding his lab, details regarding the admission in his universities. So if you are interested, you can anytime contact him for the admission. If there is any, research opportunities with him, you can always explore. I know he's really, really interested to work with different people in different areas. So if you have any area where you would like to explore, definitely you can contact him. So with that, actually, I would like to conclude this session. I would like to thank Dr. Fatur Rahman for attending this session and sharing his thoughts, sharing his research ideas with us. That's all from my side. Thank you all. Assalamu alaikum.
Thank you, sir. And we are ending our session here. Thank you.
Thank you.
Assalamu alaikum. Assalamu alaikum.
Assalamu alaikum.
Assalamu alaikum.